we're looking at cube root this time, but the process is still the same. So we're using the same formula. Change in y is f prime of x times delta x. So we need to pick our x and delta x. So, but we are now thinking about perfect cubes because this is cube root. So starting with 2 cubed, just let's list all of them. 2 cubed is 8. That's too far away from 26.27, so I don't like that one. How about 2 to the 4th power? Oh, I'm sorry, what am I doing? 3 to the 4th power. 3 cubed. That's 27. I'm just trying to find perfect cubes. I'm trying to find the perfect cube that is closest to 26.27. That's what I'm trying to do. That's why I started just listing all these perfect cubes. And I think we got it. Look, 27, 3 cubed. 27 is so close to 26.27, don't you think? Because the next perfect cubed is 64, and this is too big. It's way too big. And 8 was too small. So 27 seems just right for us to go with. So I will let x to be 27. Okay, I will let x to be 27. This is it. If x is 27, delta x is how far away is this number away from the original number. I can subtract them. I can subtract 27 minus 26.27. Okay, and that is 27 minus 26.27. So delta x is approximately 0.73. Okay, so we keep this. We say delta x is 0.73. And this is a number that we will use for this piece in the formula. Now you can see that we now need to find f prime of x. After finding f prime of x, I'm going to plug in 27 in there because that's our x value. So what is the function? The function is f of x equals cube root of x. This time it is cube root of a number. So we're going to say f of x is cube root of x, which is x raised to the 1/3 power. And I rewrite it because I'm going to use the power rule to find the derivative. F prime of x is 1/3 times x to the -2/3 power. Because 1/3 minus 1 is -2/3. If I rewrite this in a slightly prettier format, wouldn't that be 1/3 times cube root of x raised, and that will be, this will be squared. Okay, so I'm gonna go ahead and plug in 27 in this function. So what is f prime of 27? That will be 1/3 times 3 cube root of 27 squared. And that is 1/3 times, well, I'm going to do the root first, okay? Cube root of 27 is 3. So I'll say that's 3 squared. But I must simplify the, I think I'm going to try to write it under so that I can use the room on the right to write the final answer. So let me go on. 1/3 times, this time I'm squaring the 3. That will give us 9. Therefore, f prime of 27 comes out to be 1/27. Okay? So f prime of 27, oh, not double prime, f prime of 27 is 1/27. Why does it matter? Because this was part of the formula. I need this fraction as my f prime of x. So we have everything. We are ready to find delta x, right? We're ready to find delta x. Just trying to make some room for my final answer. So let's find delta x. Delta y, sorry, I keep saying delta x. Delta y is approximately, what's the formula? F prime of x. So f prime of 4027 times delta x, which is this decimal right there. So let's find what that is. Delta y is approximately 1 over 27 times 0.73, the orange and the green multiplied. So what is that approximately? 1 over 27, so I'll go ahead and do 1 divided by 27 first, and then I will multiply this decimal by 0.73, and that comes out to be 0.027, okay? All right, so let's write the final answer then. Cube root of 26.27 is approximately cube root of 27, or hold on a second. We have been adding, right? Because the number we picked were always smaller than the actual number in the square roots, okay? Or in this case, cube root. But this time, 26.27 is smaller than 27. So you know what? We're not going to add delta y. I'm going to have to subtract because cube root function, I mean, this is increasing, so I need to go down. If x became smaller, the y will also become smaller. So I'm going to have to subtract delta y this time instead of adding. Oh, that one was a little bit different this time. So what is that? Cube root of 26.27 is approximately, first of all, cube root of 27 is simply 3. So I'll write down 3 minus, we know what delta y is. Delta y is 0.027. So cube root of 26.27 is approximately 3 minus 0.027, which is 2.973. So I think I don't know, is this correct? Let's check it. Let's see how close we got. If I type in 26.27 cube rooted in this calculator, it says it should be about 5.1254. So something doesn't seem right. Let me try one more time, okay? 26.27. I think I accidentally hit the square root button. So let me hit the cube root button one more time. Ta-da! Now that's much better. So the cube root of 26.27 according to a calculator is 2.9727, and our approximation using calculus was 2.973. So I think we got very close to the actual thing. So this is how you can use differentials of y to estimate a perfect cube, a cube root of a non-perfect cube, and it involved this formula, delta y equals f prime of x times delta x. So those were the only 3 examples that I had prepared on estimating or approximating square root or cube root expressions. But if you want me to show you another one, just email me the problem, okay?